Hello everyone. A capacitor is made of a flat plate of area A and a second plate having a stair-like structure as shown in figure. The width of each stair is A and the height is B. Find the capacitance of the assembly. So from this picture we can say that there are three capacitors are connected. How they are connected? They are connected in parallel. So you can look at this one. If you provide the positive potential to the stair-like structure, so that means this is a positive, this is also positive, this is also positive. And if you provide a negative potential at the plate here at the bottom, you can say there are three capacitors which are connected in parallel. Which are the three capacitors? One is this capacitor. You can see this is the one capacitor. This is the one capacitor, and this is the another capacitor. Look at this one. This is the another capacitor, and one more, the last one. This is the third capacitor. Look at this one. This is the third capacitor. So if I say the capacitance, this is the C1, this is C2, and this is C3. You can see here these three capacitors are connected in parallel. So what is the effective capacitance? Effective capacitance C effective is equal to C1 plus C2 plus C3. Now let's calculate what is the C1, C2, C3. So capacitance basic formula C is equal to epsilon 0 A divided by D. So now let's calculate what is the each capacitance. So we can say here the each capacitance C1 is equal to epsilon 0. What is the area? If area we have taken as the capital letter A, the area of the first capacitance become what? A by 3. Okay, this is A. This distance also width is also A. This width is also A. So the area become each one is A by 3. This is also A by 3 and this is also A by 3. This distance is D, and for the second capacitance B plus D, and for the third capacitance, what is this width for third capacitance? That is equal to D plus 2B, because this is also B. So D plus 2B. Now you substitute the value epsilon 0 A divided by 3 divided by D. Okay, so we got the capacitance C1 is equal to epsilon 0 A divided by 3D. Same way capacitance C2. What is the capacitance C2? Epsilon 0 A divided by 3. Okay, once again area is divided by 3 divided by distance. What is the distance here? From this point to the second plate, this plate, that is equal to B plus D. So we got the second capacitance. Once again third capacitance epsilon 0, once again area is divided by 3. Okay, area into A by 3. And what is the distance now? This is B, this is B, so 2B plus D. So the distance here 2B plus D. So we got C1, C2, C3. Now you substitute the value in the C effective. What is the C effective? C effective is equal to C1, that is epsilon 0 A divided by 3D, plus what is C2? Epsilon 0 A divided by 3 into B plus D, plus what is C3? Epsilon 0 A divided by 3 into 2B plus D. Now solve this one, we will be getting C effective is equal to what? All things can be taken as a common one. Epsilon 0 A divided by 3 can be taken as common. Then 1 by D plus 1 by B plus D plus 1 by 2B plus D. Now solve this one, we will be getting what? Maybe you can also take the D outside. So C effective is equal to epsilon 0 A divided by 3D into 1 plus, if you take the D outside, I can write here 1 by B by D plus 1 plus 1 by 2B by D plus 1. Okay, that means C effective is equal to epsilon 0 A divided by 3D into 1 plus D divided by B plus D plus D divided by 2B plus D. So if you solve this equation, you will be getting C effective is equal to epsilon 0 A divided by 3D into 2B square plus 3D square plus 6BD all divided by B plus D into 2B plus D. This is the final answer. Hope you understood this one. Thank you.